Preparing for a technical interview at Tech Mahindra interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. Explain the 4 pillars of object-oriented programming with a practical example. Object-oriented programming organizes software around objects that combine state and behavior. Encapsulation hides fields behind methods, abstraction exposes only essential operations, inheritance reuses behavior, and polymorphism allows one interface to support multiple implementations. For example, a payment interface can have card payment and UDP payment classes, each implementing pay differently. I prefer composition over deep inheritance when relationships change frequently, because it reduces coupling and keeps responsibilities easier to test. While answering, define encapsulation, abstraction, inheritance, and polymorphism. Connect each concept to maintainability and reuse. Use a practical example such as payment processing, mention interfaces, access modifiers, and runtime method overriding. Question 2. How would you find duplicate elements in an array, and what is the most efficient approach? I would scan the array once with a hash set. For each value, I check whether it already exists. If so, I record it as a duplicate, otherwise I insert it. This gives average O, n, time and O, n, additional space. If modifying the array is allowed and values lie within a known range, in-place marking can reduce space. Sorting is another option, but it costs O, n log n, and may disturb the original order. Make sure to cover the hash set approach, time and space complexity, input constraints, ordering requirements, duplicate frequency, and alternatives such as sorting or in-place marking when memory is restricted. Question 3. What is the difference between an abstract class and an interface in Java? An abstract class represents a shared base with common state, constructors, and implemented methods, while an interface primarily defines a contract that unrelated classes can implement. A Java class can extend only one abstract class but implement multiple interfaces. I use an abstract class when subclasses genuinely share identity and behavior. I use interfaces for capabilities such as serializable or payable. Default methods provide limited implementation without removing the interface's contract-oriented purpose. In your answer, compare state, constructors, method implementations, inheritance rules, default methods, and design intent. Explain when shared base behavior is appropriate versus when capability-based contracts are preferable. Question 4. How would you optimize a slow SQL query in a production application? I first reproduce the issue and inspect the execution plan rather than guessing. I check whether filters and joins use suitable indexes, avoid selecting unused columns, remove unnecessary joins, and verify that predicates remain index-friendly. I also examine cardinality estimates, statistics, pagination strategy, and application-generated query patterns such as n+1 calls. After changing the query or index, I benchmark realistic workloads and monitor latency, CPU, locks, and regression risk. Be sure to mention execution plans, indexes, selective predicates, joins, projection, pagination, statistics, parameterization, and measuring before and after. Discuss avoiding functions on indexed columns and unnecessary database round trips. Question 5. Explain normalization and denormalization, and describe when you would choose each. Normalization organizes data to minimize duplication and prevent insert, update, and delete anomalies. For example, customer details should usually live separately from orders and be referenced by an identifier. Denormalization intentionally duplicates data to reduce joins and improve read performance, often in dashboards or high-volume reporting. I start with a normalized transactional model, then denormalize only after measuring a bottleneck, adding clear ownership, refresh rules, and consistency safeguards. Focus on reducing redundancy and update anomalies through normalization. Contrast read performance and storage trade-offs in denormalization. Include transaction boundaries, reporting workloads, indexing, and consistency risks. Question 6. What happens when you create a thread, and how do processes and threads differ? A process owns an isolated address space and operating system resources, while threads share their process's heap and code but retain separate stacks and registers. Creating a thread involves allocating its control structure and stack, scheduling it, and eventually running its instructions. Threads are cheaper for shared work but require synchronization around shared state. I would use locks, atomics, or message passing deliberately, because concurrency improves throughput only when contention and coordination remain controlled. Cover process isolation, shared address space, stack and heap behavior, scheduling, context switching, synchronization, lifecycle states, and the benefits and risks of concurrency, including race conditions and deadlocks. Question 7. How would you detect and prevent deadlocks in a multithreaded application? Deadlock requires mutual exclusion, hold and wait, no preemption, and circular wait. I prevent it by acquiring multiple locks in one global order, keeping critical sections short, avoiding nested locks where possible, and using timed acquisition for recoverable workflows. During diagnosis, I inspect thread dumps for blocked cycles and correlate them with code paths. Lock-free designs or message passing can reduce risk, but they introduce their own complexity and correctness requirements. Mention the 4 necessary conditions: consistent lock ordering, timeouts, lock scope, resource allocation strategies, detection through thread dumps, and recovery approaches. Distinguish prevention from diagnosis. Question 8. What is the difference between TCP and UDP, and when would you use each? TCP is connection-oriented and provides reliable, ordered delivery through acknowledgements, retransmission, flow control, and congestion control. UDP is connectionless, has lower overhead, and does not guarantee delivery or order. I would use TCP for HTTPS, APIs, and file transfers where correctness matters. I would choose UDP for latency-sensitive voice, gaming, or streaming when applications can tolerate loss or implement their own recovery. The choice depends on delivery guarantees, not simply speed. Compare connection establishment, reliability, ordering, flow control, congestion control, overhead, and latency. Provide suitable examples such as web traffic, file transfer, streaming, gaming, and DNS. Question 9. How does a REST API differ from SOAP, and how would you design a reliable REST endpoint? REST uses HTTP resources and verbs with lightweight representations, commonly JSON, while SOAP is a protocol built around XML envelopes, formal contracts, and enterprise extensions. For a reliable REST endpoint, I validate input, authenticate and authorize requests, return meaningful status codes, define a consistent error schema, support pagination, and make retrievable operations idempotent. I also version breaking changes, apply rate limits, log correlation identifiers, and document the contract with OpenAPI. Discuss resource-oriented URLs, HTTP verbs, status codes, statelessness, JSON, SOAP contracts, security, validation, idempotency, pagination, versioning, and consistent error responses. Question 10. What is the difference between authentication and authorization in an enterprise application? Authentication answers, "Who are you?" while authorization answers, "What may you do?" A login flow authenticates a user using credentials or an identity provider, then issues a session or token. Authorization evaluates roles, claims, resource ownership, and policy before allowing an operation. I apply least privilege, short-lived access tokens, secure password hashing, TLS, and audit logging. OAuth delegates access, but it does not replace authorization decisions inside the service. Make sure to distinguish identity verification from permission checking, cover sessions, tokens, OAuth concepts, roles, claims, least privilege, expiration, revocation, and secure password handling. Question 11. How would you design a scalable URL shortener or similar small web service? I would expose a create endpoint that maps a long URL to a unique short key and a redirect endpoint that resolves the key. Stateless application servers can scale behind a load balancer. A database stores the mapping while a cache serves popular redirects. I would use a collision-resistant ID strategy, validate URLs, support expiration, rate limit abuse, and replicate data for availability. Analytics should be asynchronous so redirect latency remains low. Cover API design, unique key generation, database choice, caching, redirection latency, collision handling, expiration, replication, rate limiting, analytics, and horizontal scaling with stateless application servers. Question 12. What is caching, and how would you handle stale data and cache failures? Caching stores frequently accessed data closer to the application to reduce latency and database load. In a cache-aside design, the application reads the cache, fetches from the database on a miss, and then populates the cache. I define TTLs based on business freshness, invalidate or update entries after writes, and use request coalescing to avoid stampedes. If the cache fails, the database remains the source of truth, with protection through rate limits and fallback controls. Discuss cache-aside, read-through and write-through patterns, TTL, invalidation, eviction policies, consistency, cache stampedes, fallback behavior, and whether stale data is acceptable for each business operation. Question 13. Explain ACID properties and their importance in transaction processing. ACID means atomicity, consistency, isolation, and durability. In a money transfer, atomicity ensures debit and credit succeed together, consistency preserves constraints, isolation prevents concurrent transactions from producing invalid observations, durability keeps committed data after failure. Databases implement these through logging, locks, multiversion control, and recovery mechanisms. I choose an isolation level based on correctness and throughput, because stronger isolation reduces anomalies but can increase blocking or resource usage. In your answer, define atomicity, consistency, isolation, and durability. Connect them to commits, rollbacks, constraints, locking, logging, isolation levels, and business examples such as money transfers. Question 14. How does garbage collection work in Java, and how would you investigate memory issues? Java garbage collection identifies objects no longer reachable from live routes and reclaims their memory. Generational collectors exploit the fact that most objects die young, while long-lived objects move to older regions. To investigate memory issues, I inspect heap usage, allocation rates, GC pauses, logs, thread behavior, and heap dumps for unexpectedly retained references. I fix ownership or lifecycle bugs first, then tune heap size or collector settings using production-like measurements. Mention reachability, young and old generations, pauses, allocation rates, heap dumps, garbage collection logs, metrics, memory leaks through retained references, and tuning only after identifying the actual cause. Question 15. What is the purpose of unit, integration, and system testing in a software project? Unit tests isolate a small component and provide fast feedback. Integration tests verify collaboration with databases, queues, or external services, and system tests validate end-to-end behavior. I use many focused unit tests, fewer integration tests, and a small number of valuable end-to-end tests. Mocks should isolate unstable boundaries, not conceal real integration problems. I also include contract tests for service APIs and run tests automatically in the delivery pipeline. Compare test scope, speed, isolation, dependencies, confidence, and maintenance. Explain mocking boundaries, contract tests, regression coverage, test data, and the test pyramid. Question 16. Describe a secure and efficient exception handling strategy in a backend service. I treat exceptions as part of the service's failure contract. Expected validation or business failures become clear client responses, while unexpected failures are handled centrally, logged with correlation identifiers, and returned without stack traces or sensitive details. I preserve the original cause for diagnosis, avoid empty catch blocks, and retry only transient operations with bounded exponential backoff. Metrics and alerts should distinguish client errors, dependency failures, and genuine application defects. Cover checked versus unchecked errors where relevant, centralized handling, meaningful status mapping, logging context, safe client messages, retries, correlation IDs, and avoiding swallowed exceptions are sensitive information exposure. Question 17. How would you implement a binary search, and what common mistakes should you avoid? Binary search requires a sorted collection and repeatedly halves the search interval. I maintain inclusive low and high boundaries, calculate mid as low plus half the difference to avoid overflow, and discard the half that cannot contain the target. The iterative version uses O(1) space and O log n time. I test empty arrays, one element, missing values, duplicates, and boundary targets, because incorrect updates commonly cause infinite loops. Be sure to explain the sorted input requirement, loop invariant, midpoint calculation, boundary updates, duplicate handling, complexity, and overflow safe arithmetic. Discuss iterative versus recursive implementations. Question 18. What are the advantages of microservices, and what challenges do they introduce? Microservices split a system into independently deployable services aligned with business capabilities. They can enable team autonomy, targeted scaling, and fault isolation, but introduce network failures, operational overhead, distributed tracing, eventual consistency, and complex deployments. I would begin with clear domain boundaries and independent data ownership, not service count. For a small product or inexperienced team, a modular monolith often delivers faster while preserving a path toward later extraction. Discuss independent deployment, team ownership, scaling, fault isolation, service boundaries, network latency, observability, distributed transactions, deployment complexity, data ownership, and when a modular monolith is safer. Question 19. How would you troubleshoot a production API whose response time suddenly increased? I first confirm whether P50, P95, or P99 latency changed and identify the affected endpoint, region, and release. Then I correlate metrics, distributed traces, logs, database performance, dependency timings, traffic volume, CPU, memory, and connection pools. I mitigate quickly through rollback, scaling, traffic shaping, or feature disabling when appropriate. After recovery, I reproduce the failure, document the root cause, add monitoring or tests, and verify the fix under realistic load. Mention defining the affected percentile, checking recent changes, dashboards, traces, logs, dependency latency, database plans, resource saturation, traffic patterns, rollback, mitigation, and a follow-up root cause review. Question 20. Tell me about a technical project you built and the engineering decisions you made. I describe projects using problem, approach, result, and learning. For example, I might explain a service that automated ticket processing, including my API design, database schema, validation, testing, deployment, and monitoring responsibilities. I quantify impact such as reduced processing time or fewer failures, then explain one trade-off, such as choosing a relational database for consistency. I also acknowledge a limitation and propose a practical improvement, demonstrating ownership rather than presenting an unrealistically perfect system. Focus on the problem, users, architecture, personal contribution, technology choices, trade-offs, testing, measurable results, failure or learning, and how you would improve the solution with more time. If you are still with us, congratulations, you are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.